Welcome back to Workplace 30. We're already on Chapter 5, which means we're starting the second half of this course. Chapter 5 is titled Properties of Geometric Figures. In this chapter, we're going to examine triangles, quadrilaterals, and regular polygons and identify their properties. So you will learn these 4 things and more. You're going to learn how to describe and show properties of triangles using side lengths and angle measures. You'll describe and show properties of quadrilaterals using side lengths, angle measures, diagonal lengths, and angles of intersection. And same thing with polygons. You're also going to be able to identify the uses of different geometric shapes. So math on the job is next on page 180. Please read that. And what we're going to do is we're going to use the Pythagorean theorem to show how this method can be used to confirm that a corner is square. So they're saying that he measured 3 inches along one edge and 4 along the other. They're not saying that that's the whole edge, but then he measured the diagonal between them. So what would that diagonal have to be to make that corner a perfect right triangle? We know that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are side lengths and c is your hypotenuse. So go ahead, try to find what the hypotenuse length would have to be. So when we plug this in, we'll find that c equals 5. So that means if your hypotenuse is exactly 5, you will have a perfect right angle at that corner. All right, then we're going to explore the math on page 180 and fill in the following definitions. You can check your definitions on the board. Make sure that if you are making something that is equilateral or that is isosceles, you're including these little marks. What those marks do is they show that all side lengths are of equal measure. Okay, then we've got some properties that we need to review before we can get going in this chapter. So there's property of interior angles. What that means is all interior angles of a triangle add up to 180 degrees. So that is key for working with triangles. Also, properties of right triangles, we have 2 different properties. We have SOHCAHTOA, which we're going to talk about here in a minute, and we also have the Pythagorean theorem, which is a squared plus b squared equals c squared. So those are the 2 main properties you'll need to know. So SOHCAHTOA, what that means is you always start with your given angle. So the angle we're looking at here, the opposite side is directly across from it, the adjacent side is beside it, and the hypotenuse is always across from the largest angle, which is always the 90-degree angle. So sine theta means opposite over hypotenuse. That's where we get our OH from. Cos is adjacent over hypotenuse. That's our AH. And tan is opposite over adjacent, which is OA. And theta stands for your angle measure. So when we see this here, that means your angle that you're working with. So properties of parallel lines is the next thing we need to review. We have all of these different types of angles, and there's lots more, but these are the main ones. So here we have 2 parallel lines, which I'm going to call L1 and L2, that are cut by a transversal, which I'm going to label T. All of the different angles are numbered. So corresponding angles means that they're in the same position relative to the vertex. So what would be one set of corresponding angles? No, 1 and 3 was the answer, and no, those would not be corresponding. So that means if I have the angle 2, it's in the top left corner. So 6 is also in the top left corner with respect to the other one. So an example here would be angle 2 and angle 6. What's one more example? Angle 8 and angle 4. Good. Please find one more set. Keep in mind that corresponding angles are always equal measure. So that means if angle 2 is 110 degrees, angle 6 will also be 110 degrees because the 2 are corresponding. Alternate interior angles have opposite sides or are on opposite sides of the transversal, but in between parallel lines. So what would be one example of that? 3 and 5. Good. They're on opposite sides of T, but they're in between L1 and L2. So, for example, angle 3 and angle 5. And again, those are always equal measure. So if angle 3 is 60 degrees, angle 5 would also be 60 degrees. So go ahead and find one more example. So angle 6 and angle 4 would be your other set of angles. Now, I had one response saying that angle 7 and angle 1 would fit into that category. Now, angle 7 and angle 1 are actually on the outside of the two lines, so we would call those alternate exterior angles, which I did not put the definition up here. So same side interior angles is next. That means same side of the transversal, but in between the parallel lines. So for example, 4 and 5 would be same side interior angles. So angle 4 and angle 5. And these angles always add up to 180 degrees. So angle 4 plus angle 5 would be 180 degrees. Go ahead and try to find the other set. So that other set would be angle 3 and angle 6. And last but not least, vertically opposite. These are straight across the vertex from each other, and these are always equal. So for example, angle 2 and angle 4 would be vertically opposite because they're directly across the vertex from each other. Another way of thinking of it is if you have two angles that come together, they're going to make an X. So for example, angle 2 and angle 4, what's one more pair of vertically opposite angles? Angle 7 and angle 5. Perfect. Now, if you need more help with this, I did provide an additional link. Here's a YouTube video. It goes through really nice and slowly all the different options and what's equal to what. There's also a PDF here that you could use as well if you're having trouble. So we're going to start by calculating the value of each one of these missing angles. So the first one here, A, we have an equilateral triangle. So since it's equilateral, that means all three side lengths and all three angles are the same. So we know that all three of these angles are the same, and they all have to add up to 180 degrees. So we'll go 180 divided by 3, so each angle is going to be 60 degrees. The next one, we have a right angle, and then a 30-degree angle. So we know that this is 90, 30, and our last angle also has to add up to 180 degrees. So that leaves us with an angle of 60 degrees. C, again, they all have to add up to 180, so we'll go 180 minus 103 minus 38 to get an angle of 39 degrees for E. Now D, this is an isosceles triangle, which means both of these two angles have to be the same. So if we go 180, because they all have to add up to 180, subtract our 48, and divide that by 2 to get two even angles, each one of these angles will be 66 degrees. So again, I went 180 minus 48 to get the total of our other two angles. Since they're both the same, we divide that by 2, and that'll give us 66 degrees each. Okay, then we're going to try some trig ratios to calculate these. So the first one here, we have a 43 degrees angle. We're looking for the opposite because this is across from it, and we have the hypotenuse. So since we have opposite, or we're looking for opposite, we have hypotenuse, that would mean we use sine, because sine is SOH, or the first part of SOHCAHTOA. So we get sine 43 equals opposite, which is x, over hypotenuse, which is 13. Now to get 13 off the bottom, we multiply to the other side to get x equals 8.9 meters. Now you need to be careful. Your calculator needs to be in degrees. If you did not get this answer, check to make sure it's in degree mode. Go ahead and try the rest of these questions. So check your answers here on the board. A few tricky things here with question B. When you have x on the bottom, you basically need to switch the places of x and tan, because you'd multiply out the x and then divide by tan 79. So you get 31 divided by tan 79, so x equals 6. Then for C, you're looking for an angle. So here, you type in your opposite over your adjacent, divide the two to get 0.46. Then you need to hit the second button on your calculator. So that'll give you an inverse sign. So it'll be tan inverse C equals 0.46. And you'll find that angle C is 25 degrees. For part D, you're looking for both angles D and E. Try it out, and you should get angle D equals 42 degrees, and angle E equals 48 degrees. So number 3, we're still finding angle measures. Just keep in mind that when you're looking for an angle, that's when you need to hit your second function button on your calculator. 4, Pythagorean theorem. That is a squared plus b squared equals c squared. Now note, you can only use this if you have a right-angled triangle. So here C is always your hypotenuse. And remember that C is always across from the right angle. So we'll get 12 squared plus 9 squared equals c squared. 12 squared plus 9 squared, and then square root your answer. So C is going to be 15 meters. Next one, you'll go through the same thing, and you'll find X to equal 16.5 centimeters. Okay, so here we've got two parallel lines, L1 and L2, and we make these little green marks on them to show that they're parallel. Let's start by finding angle 4. So angle 4 and angle 62 make a straight line, which means they have to add up to 180 degrees. So if we go 180 minus 62, we'll get angle 4 equals 118 degrees, and our reason would be that it's supplementary to angle, or sorry, not to angle, 6 to 62 degrees. Again, supplementary means that they add to 180. So we can do the same kind of thing here with angle 1. We have 114, so we could find angle 1 because they have to add up to 180. So angle 1 would be 66 degrees, and our reason is that it's supplementary to 114 degrees. Now notice that angle 1 and angle 4, they're technically corresponding, but they're not equal. The reason that they're not equal is because these two lines, let's call them line 3 and line 4, are not parallel. But if we'd have corresponding angles, for example, angle 1 and angle 3, and we know that line 1 and line 2 are parallel, that means they're the same. So angle 1 and angle 3 are both going to be 66 degrees because they are corresponding angles. Or corresponding with angle 1 is why angle 3 is 66 degrees. Now we also can find angle 2. There's a few different ways we could do this. Angle 2 and angle 3 would be considered alternate interior angles, or angle 1 and angle 2 are considered vertically opposite. Either one of those. So what would that make angle 2? Good, 66 degrees. So there's two different options. I'm going to say vertically opposite. Vertically opposite from angle 1. And then angle 5 is all that's left. So angle 5, there's a few different things we could do here. Angle 5 and angle 2 are corresponding, which would make them equal since we have two parallel lines. Or angle 5 and angle 3 are vertically opposite. So what would that make angle 5? 66 degrees also. Good. Oops, 66. There's a few different reasons that you could write there, so make sure you write one reason of your own. Okay, then you can start on the handout assignment, which is located on the Moodle.